Good evening, everyone. Welcome to iQuanta. So, quantitative aptitude revision series day 7. You know, yesterday we talked about speed maths calculation, right? And that was a very good session. Lots of our students got very good insights regarding how to do the calculation quickly. Okay. Hello, Rashmi. How are you? And before that, we had 3 sessions based on formulae from number system and 2 sessions based on arithmetic. So, if you are preparing for IPMAT, then I will suggest that go and watch all those sessions before the exams. It will be immensely helpful to you guys. Today, we are going to learn about formulae based on algebra, and the topics that we are going to discuss today is first of all we are going to discuss algebraic identities, because without algebraic identities there is no way that you will be able to solve algebra problems, right. So, first we are going to discuss algebraic identities, then we are going to discuss problems based on indices, formulae based on indices, and then linear equations, and then quadratic equations. So, some really good topics, right, some really good topics. So, let us continue with our session today, and let us start with our first part, which is algebraic identities, right, algebraic formulae, which are, as you can see, a plus b whole square is equal to a square plus 2ab plus b square. Okay, a square plus 2ab plus b square. Then a minus b whole square is a square minus 2ab plus b square. A plus b whole square plus a minus b whole square, which if you add these two, what do we get? 2ab will be cancelled out. We get 4a square plus b square. Then comes a square minus b square, which is a plus b into a minus b. Then again we are using the first and second formulae, and if you take the difference, which is a plus b whole square minus a minus b whole square, that will be equal to 4ab. Yes, Ramdut, this is for JIPMAT. Okay, this algebra basics are for will work for JIPMAT as well. Okay, hello Rashmi. Why you keep deleting your messages here? Okay, then comes a plus b whole square minus a minus b whole square, then a square b square terms will be cancelled out, we will get 4ab, and then a plus b plus c whole square, which is a square plus b square plus c square plus 2ab 2bc plus 2ca, right. And then the cube, we have many confusion regarding these formulae. So, here it is, a plus b whole cube is a cube plus 3ab into a plus b plus b cube. If you expand this, you get a cube plus 3a square b plus 3ab square plus b cube. Then comes a minus b whole cube, which is a cube minus 3ab into a minus b cube. Now, if you expand this, you might know this formula in that way, that a minus b whole cube is a cube minus 3a square b plus 3ab square minus b cube. And then we get a cube minus b cube, which is a minus b into a square plus ab plus b square. Then comes a cube plus b cube, which is a plus b into a square minus ab plus b square. So, these are the important algebraic identities that will be used throughout. Okay. Ramdut, as I said, that I am trying to cover every small formula here, all the topics that I am taking the session. Okay, I am trying to cover every small formula. So, if you are watching them closely, yes, that should be enough. Okay, that should be enough. I do not think that you will have to learn any other formula from anywhere else. Okay, and also thanks for your lovely words. That is really made my day. Then comes one more important algebraic formula, which is AQ plus BQ plus CQ minus 3ABC, which is equal to, now this is important, focus on this, because if questions are there on the basis of algebraic identities, then this is with most probability. A plus B plus C into this should be A square, right? This should be A square plus B square. Let me make the correction here as well. This should be A square. Yeah, now you can note it down freely, you won't have any issue. So it will be A plus B plus C plus A square plus B square plus C square minus AB minus BC minus CA, right? And then we can also write it as 1 by 2 A plus B plus C into A minus B whole square, B minus C whole square and C minus A whole square. This will come in one bracket, right? All right. Now application of this, see, can I say if A plus B plus C is equal to 0, if this part is 0, if this part is 0, this whole right hand side will become 0, right? That means AQ plus BQ plus CQ will be minus 3ABC will be equal to 0. So from there we are getting AQ plus BQ plus CQ will be equal to 3ABC, which is this one. Then again, if we say that AQ plus BQ plus CQ is equal to 3ABC, that means this is equal to 0. If AQ plus BQ plus CQ is equal to 0, if left hand side is equal, that means either this is 0 or this whole expression is 0, right? Means this is 0 or this whole expression is equal to 0. So you can see A plus B plus C is equal to 0, or A minus B whole square plus B minus C whole square plus C minus A whole square will be equal to 0. Now we know that A minus B whole square will always be greater than equal to 0. So if sum of these three terms is equal to 0, that means each of them will be equal to 0, right? None of them can be negative. Hello Nityam. So then we say that AQ plus BQ plus CQ is equal to 3ABC. Then we can say A plus B plus C is equal to 0, or we can also use this result that A is equal to B is equal to C. All right. I hope this is clear to each one of you. If you want to note down this algebraic identities, then note it down. This was the first slide. This is the second one, right? Okay. Now, then comes the fundamental rules of indices. Indices means powers. When we are talking about powers, what are the rules that we need to follow, right? कल कौन सा टॉपिक की क्लास होगी? रामदूत, कल की क्लास में मोस्टली वी आर गोइंग टू कवर व्हाट कैन आई से, लॉगरिदम, इनइक्वालिटीज एंड मॉड्यूलस, है ना? दीज थ्री. सही है? ठीक है? Okay. Then if you talk about this, what are the rule of indices? A to the power m into A to the power n is equal to A to the power m plus n. For example, if you take 2 to the power 3 into 2 to the power 4, this will be equal to 2 to the power 7. Okay, the power will be added. The second one, A to the power m divided by A to the power n is equal to A to the power m minus n. Means if we have 2 to the power 7 divided by 2 to the power 4, this will be equal to 2 to the power 3, which is 7 minus 4. Okay. Okay. Rashmi, geometry is scheduled, but after algebra. Okay. So I'm really sorry for that. But let me talk to the management. Okay, if I can take a session on geometry tomorrow. Okay. Then comes A to the power m to the power n. Then this is equal to A to the power m to the power n, and that is not equal to A to the power m to the power n. Let's say if we have 2 to the power, let's say 5 to the power 6. So this will be equal to 2 to the power 15625. But if we have 2 to the power 5 to the power 6, this will be equal to 2 to the power 30. and if you have 2 to the power 6 to the power 5, this will be equal to 2 to the power 30. And so in these type of situations, okay, remember, be careful here, okay, that these two are not equal, these two. So that's why a to the power m to the power n is equal to a to the power m into n, but this is not equal to a to the power m to the power n. Then a to the power minus m is equal to 1 upon a to the power m, meaning 2 to the power, let us say 2 to the power minus 4, which will be equal to 1 by 2 to the power 4 and vice versa. Okay. Then mth root of a is a to the power 1 by m, means if you try to find cube root of a, let us say cube root of 8, we can write 8 to the power 1 by 3. Now what is 8? 8 is 2 to the power 3, then it will be 2 to the power 3 to the power 1 by 3, which can be written as 2 to the power 3 into 1 by 3 using this one, the third one. This will be equal to 2 to the power 1. Okay, this is what it says in fifth point. Then a to the power n into b to the power n will be equal to a to the power a into b to the power n. And similar concept is seventh, a to the power n divided by b to the power n is a by b to the power n. Now a to the power 0 is equal to 1. Why a to the power 0 is equal to 1? Because you can see a to the power 0, can I say a to the power 0 can be written as a to the power m minus m, right, and then it can be written as a to the power m divided by a to the power m, which will be equal to 1. Okay, so that's why a to the power 0 is equal to 1. All right, then comes a to the power x is equal to a to the power y. That means two things, means a is equal to 1, either a is equal to 1 or x is equal to y. Both the situations are possible. All right, both the situations are possible. A to the power x is equal to a to the power y. When this is given, then you need to follow. It could be any expression as well. Okay, it could be any expression, like let's say 5 to the power 5 minus x to the power 3 is equal to x plus 2 to the power k. Then what are the possibilities? Okay, what could be the values of x or what could be the value of k? So there will be two different possibilities. First case, we can say 5 minus x will be equal to x plus 2, right, or 2x is equal to 3, or x is equal to 3 by 2, or second condition it will be that 3 is equal to k. Sorry, not 3 is equal to k. In this case, there will be this case only where these two are equal and 3 is equal to k. Yes, 3 is equal to k. All right. So this is what we need to understand from there, that if a to the power x is equal to a to the power y. All right, then either both of them. Now if this is not 1, this is not 1, right? If this is not 1, then what we can say, that in that case this should be equal to this. All right, k should be equal to 3. Okay. All right then. Next we come to linear equations. So now in linear equations we need to understand three different kind of linear equations. One of them is linear equation with one variable. Okay, linear equations with one variable, and in case of one variable, when we write the correct expression, the given statement into correct expression, the form, the general form of one variable equation will be ax plus b is equal to 0, or we can say x is equal to minus b by a. This is how you find the value of the variable here. If there are two variables equation, let's say if there are two variables, then what do we say, that one of the equation, the general form of this equation will be ax plus by is equal to c. Now if there is only one equation and two variables, there will be infinitely many solutions if there is no condition given. If no condition is given, there will be a infinite solution. But if there are two two equation given, two independent equations given, like a1x b2y, if b1y is equal to c1 and a2x plus b2y is equal to c2. If we have two equations like this, then how do we solve it? So, one way to solve it is making the coefficient same and then solve the equation, but not always you are going to get unique solution. There are some conditions that we need to follow. What are those conditions? That condition 1, case 1, when we say a1 by a2 is not equal to b1 by b2, then we have unique solution. Then we have unique solution. That means then only one value of one pair of x and y will satisfy both the equations. Okay. Then if we talk about case 2, which is a1 upon a2 is equal to b1 upon b2, and that is equal to c1 upon c2. In that case, we will have infinite solution. We will have infinite pairs of x and y which will satisfy both of these equations. Okay. Then comes case 3, and in case 3 we say a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. Then in that case we say there will be no solution. No solutions. Okay. Now I will give you one example in each case. Let us say we have 2x plus 3y is equal to 7. Then we have x plus 2y is equal to 8. So you can see in this case 2 by 1 is not equal to 2 by 1 is not equal to 3 by 2, right? 2 by 1 is not equal to 3 by 2. So in that case we will have unique solution. Now in these kind of situation, let us say we have 2x plus 3y is equal to 7, and we have 4x plus 6y is equal to 14. Then a1 by a2, b1 by b2, c1 by c2, all of these three ratio will be equal to 1 by 2. So in that case we will have infinite pairs of x and y which will satisfy both the equations. All right. Then comes the case 3, where a1 by a2 is equal to b1 by b2, which is not equal to c1 by c2, meaning let us say 2x plus 3y is equal to 7, but we have 4x plus 6y is equal to 8. Now the ratio of a1 by a2 is equal to b1 by b2, which is 1 by 2, but that is not equal to c1 by c2, which is 7 by 8. So in that case we won't have any solution. We won't have any solution. So if you get a question like this, you can directly apply these concepts and find out the answer. Okay. Tell me, is this clear to you guys? Are you aware of these concepts? If you are aware of these, then that's really good for you. But if you are not, then you can note it down, right? Yes, aware. Okay. Then let's come to the general equation of nth degree polynomial. Let me keep this, put this a little up. Okay. So general equation of nth degree polynomial of x. Now try to give it a read, and then we are going to discuss each of these in details. All right. Monster RDX, very dangerous name. And sir, I am appearing for JIPMAT 2025. LR and VA I am able to score good, but QA is still behind. Out of 33, I am able to attempt only 3-4 questions. Please help. Okay, see, out of 33 questions, if you are able to attempt only 3-4 questions, that means clearly you have not practiced well, right? You have not practiced well, and you have conceptual problem like in every topic. So what I will suggest you that just try to cover all the quant formula revision sessions that we have taken till now, okay, and those sessions are of 1.5 hour. So till now we have done 7 session, so it might take you some time before you finish all those sessions, but you can take this number of questions from 3-4 to a higher number, okay, maybe that will also help you clear the cutoff. All right. So in this short period of time, what I will suggest that try to solve previous year questions of JIPMAT as well as try to watch these sessions, these two things, okay, Monster RDX, these two things, you do this and you won't be having problems, not like this that you are having right now, like you are able to solve only 10% of the questions. So you can improve these values. All right. Now, have you guys read this? Let me know once you are done. I have also put an example here for this one, and I will try to explain the rest of them as well. Once you are done with reading these information, then you can write done in the comment section, okay, so that I can continue with explaining these. All right. Okay, done. All right. Okay, Rashmi, done. Okay. So let's try to understand it. What do we call a polynomial, right? What do we call a polynomial? So polynomial of fx, it says let polynomial of fx a0 x to the power n, a1 x to the power n minus 1, a2 x to the power n minus 2 till an, where a0, a1, a2 are rational numbers and n is a non-negative integers. N is the power is a non-negative integer. It can be 0. When it's 0, then we say that it's a constant term. The power of x is 0 here. That's why it's a constant term. Then the values of x for which fx becomes 0 are called root of the equation fx is equal to 0. The highest power of x is called the degree of the equation, meaning if we have an equation x square minus 5x plus 6 is equal to 0, right, then we say that this is a polynomial of polynomial of x. X square minus 5x plus 6 is a polynomial of x with a degree 2, quadratic. Now if you expand it, you write it x square minus 3x minus 2x plus 6, which I can write if I take x common, x minus 3 minus 2 common, x minus 3, then this will be equal to x minus 3 common, then we get x minus 2. Now think about this. If I put x is equal to 3 here, this whole expression will become 0. If I put x is equal to 2 here, this whole expression will become 0. So we can say that if this is equal to 0, then what are the values of x which are satisfying it? X is equal to 2 or 3. That means x is equal to 2 or 3 are the roots of this equation. All right. This is what do we mean by polynomial. This is what do we mean by degree. This is what do we mean by roots, or as well as we call it solution. What is the solution of this equation? 2 and 3. So is it clear to you guys what is polynomial, what is degree, what are roots, you know? So now the degree is mentioned here. Example has been given x to the power 4, something like this. This is an equation with degree 4. This is an equation with degree 5. This is linear equation because degree is 1. Then comes this will be quadratic. This will be cubic equation. Now next one, it says that for degree n, fx is equal to 0 will have n roots. Okay, for degree n, fx is equal to 0 will have n roots, including real and imaginary. So total number of roots, total number of real and imaginary roots will be equal to n if any equation has degree of n. Then comes if r1, r2, r3, rn are the roots of fx is equal to 0, then fx will be this. Comparing this, that 2 and 3 are the roots of equation. So what we can say, fx 2 and 3 are the only roots of the fx is equal to 0. Then we can say fx is equal to x minus 2 into x minus 3, which will be equal to x square minus 5x plus 6. All right. Now if we say that 1, 2, 3 are the only roots of fx is equal to 0, then we can say that fx will be equal to a into x minus 1, x minus 2, x minus 3. Okay, this will be the value of fx. Okay, these are the only roots. Last 2 points. In case of last 2 points for degree fn, see this degree is 2 here, right? Degree is 2 here, so there will be 2 roots like this one, 2 and 3. If degree is 3, let's say we have an equation something like x cube plus 2x square plus x plus 7 is equal to 0. So this will have 3 roots. Okay, this will have 3 roots. 1 real root, 2 imaginary roots, possible. All 3 are real, possible. So this will have exactly 3 roots. If degree is 5, that equation will have 5 roots. Now the third point I am explaining here, Rashmi. All right, like this one, fx is equal to a into x minus 1 into x minus 2 into x minus 3. If it's given that 1, 2 and 3 are the only roots of fx is equal to 0. So if you expand this, you can find the equation, right? If you expand this, you can find the equation. Is that true? इन्हें मल्टीप्लाई करके एक आ जाएगा ना पोलिनोमियल x के टर्म में, आएगा कि नहीं बताओ? जैसे देखो, इससे मल्टीप्लाई कर सकते हैं ऐसा, a इंटू एक्स माइनस 1 एंड दिस विल बी एक्स स्क्वायर माइनस 5x प्लस 6. Now if you multiply this, this will be x cube minus 5x square plus 6x minus x square plus 5x minus 6, which gives us a into x cube minus 6x square plus 11x minus 6. See, so this is our equation. If this is our equation, so if roots are given, we can find the equation. Is that clear now? All right. So this should be this should be our equation if roots are given. All right. Okay. Now then let's come to next part of understanding more about polynomials. So try to give it a read. I have written down all of you guys for all of you guys, so that in short period of time we can learn more and more about polynomials and equations. So try to give it a read. Let me know once you are done. Okay. Ramdot, see, for JIPMAT, the cutoff is 50 percentile, okay. The cutoff is 50 percentile, and to achieve 50 percentile in each section, it's not very difficult. So what I will suggest is you should go with the flow. You don't need to worry more about how many questions and what. Try to solve as many questions as possible, all right. Okay, are you guys done with this? Let me know once you are done. Hello, Akshit. Done. So it says in an equation with real coefficients, imaginary roots occur in pairs. So whenever you are getting imaginary roots, it will always be in pairs, okay. There cannot be one imaginary roots or three imaginary roots or five imaginary roots. If let's say there is an equation of degree 7, so number of imaginary roots of this equation can be 2, or it can be 4, or it can be 6. So number of imaginary roots of any equation can only be 2 or multiple of 2. So either it can be 0, 2, 4, 6, 8 and so on. It cannot be odd number of roots which are imaginary, okay. So it's also given that they will be, how will those roots look like? So imaginary roots look like p plus iq. Iq means I is the iota, all right. So I is the iota. So p plus iq is a root of the equation fx is equal to 0. Then p minus iq will also be the root of the equation. Let's say for example x square minus 7x plus, let's say something, what we can say is 10 is equal to 0. So what will be the roots of this equation? Okay, so what we can say, roots are using the formula 7 plus minus square root of 49. Let's say this is, instead of 10, let's say this is some big number, a little bigger than this, something about 15, okay, 15. So this will be 49 minus 60, so minus 11 upon 2. So this will be 7 plus root 11I by 2. This will be one root, and the other root will be 7 minus square root of 11I by 2. So you can see these are in conjugate pairs. Whenever you are getting imaginary roots, they will be in a pair like this. If one imaginary root is given, you can find the another imaginary root. Let's say if one imaginary root is given, that one of the imaginary roots of an equation is 5 minus 6i, then you can freely say that other imaginary root will be 5 plus 6i. You know? So this is what it means that if one of the roots is p plus iq, okay, then other root must be p minus iq, okay. In an equation, fifth point, in an equation with rational coefficients, irrational roots occur in pairs, okay, and p plus root 2 is a root of the equation, then p minus root 2 will also be a root of the same equation. Agar, remember, if the coefficients are rational, अगर coefficient rational है, irrational नहीं, मतलब ऐसा नहीं हो सकता कि you are talking about root 3x square plus 2x plus 7 is equal to 0. Not like this. This is irrational. This root is irrational. So we are not talking about these type of equation. We are talking about equation where all the coefficients are rational. Okay, it could be fraction, it could be integers, but it should be rational. Okay, this is what it says here. And if in those cases one of the irrational root is p plus root q, other will be p minus root q. Okay. Now it says will also be a root of the same equation. जैसे 3 plus root 4 is a root. चलो एग्जाम्पल देता हूँ इसमें भी. लेट्स से कि x square प्लस 4x माइनस क्या ले लें, -6 इज इक्वल टू 0, कुछ ऐसा ले लेते हैं ना। सो क्या हो जाएगा, इसके रूट्स क्या हो जाएंगे, what will be the roots of this equation will be equal to -4 plus minus square root of 4 square minus 4 into 6 into 1, अच्छा प्लस 6 ले लो, सो ये प्लस आ जाएगा, डिवाइड बाई 2 विच विल बी इक्वल टू -4 प्लस माइनस दिस विल बी 24 plus 16 40, square root of 40 by 2, which we can write -4 plus minus 40 is nothing but 4 into 10, so this I can write 2 root 10 by 2, which will be equal to -2 plus minus root 10, है ना। As you can see, if one of the root is 10 root 10 plus 2, then other root is root 10 minus 2. So in these kind of scenarios, if all the coefficients are rational, then the irrational roots will be always in conjugate pairs, just like this. If one of them was 10 plus root 2, other will be 10 minus root 2. Is that clear? Batao. Is that clear? Ramdut, Rashmi, Akshit, Monster, Anjali, is that clear to you guys? बताओ। ठीक है, means if one of the root is given, then you can find the other root. One of the irrational root is given, you can find the other irrational root, then you can find the equation. Now it says if the coefficient of an equation are all positive, then the equation has no positive roots. Equation like this, है ना, कितना अच्छा statement है ये. Without solving the equation, we can say that how many positive roots will be there, how many negative roots will be there in these kind of situation, like 3x to the power 4 plus x square plus 2x plus 1 is equal to 0. How many roots of this equation are positive? What will be your answer? 0, because all the coefficients are positive, है ना, all the coefficients are positive. Another example we can take 5x to the power 5 plus 4x to the power 4 plus 3x to the power 3 plus 2x square plus x plus 10 is equal to 0. How many roots of this equation are positive? What do you say? How many roots of this equation are positive? Right? Sarthak, tell me how many roots of this equation are positive? Rashmi, Ramdut, Akchet, Monster RDX, बताओ क्या कह सकते हैं इसके रूट्स के बारे में? हाउ मेनी रूट्स ऑफ दिस गिवन इक्वेशन इज पॉजिटिव? चेक द सिक्स्थ स्टेटमेंट. The answer is hidden in plain sight, right? So you can simply follow this. It has no positive roots, right? All the coefficients are positive, so it has no positive roots. All right. Then point 7, it says the common roots for equations fx is equal to 0, gx is equal to 0 is obtained by fx minus gx is equal to 0, with the condition that roots of fx minus gx is equal to 0 also satisfy fx is equal to 0, है ना. If you have two equations, okay, if you have two equations, let's say something like one equation is 2x cube minus 2x square plus 5x plus 1 is equal to 0, and you have another equation something like 2x cube plus 5x square plus 7x, है ना, plus let's say plus 15 is equal to 0. So this equation will have three roots. This equation will have three roots. How many roots are common in these two roots? How many roots are common in these two equations? Sorry, how many roots are common in these two equations? So what do? You take the difference of these two equations. If you take the difference, if I subtract this 5x square minus 2x square, 7x square, this will be 2x प्लस, है ना, क्या हो जाएगा ये 15 माइनस 1 इज 14. कुछ और लेते हैं, है ना, कुछ और लेते हैं. लेट से कि यहाँ पे अगर मैं लूँ कुछ ऐसी वैल्यू जिससे कि थोड़ा मज़ा आए सॉल्व करने में. कुछ ऐसा लें, इसे -64 ले लें, इसे -64 ले लें. सो दिस विल बी माइनस नहीं -64 नहीं, -10 ले लो, है ना, -10. So this will be -9 is equal to 0, right? So in these kind of situation, what do we do? So first of all we take the difference. If you took the difference, now you can break it like 7x square plus 9x minus 7x minus 9 is equal to 0, or this can be written as 7x x plus 9 then minus 7 x plus 9 is equal to 0, or this will be equal to x plus 9 we can take common, है ना. One second. This should be x common here. We should take x common here. Then it will be 7x plus 9. Then we took minus 1 common here. Then we get 7x plus 9 is equal to 0. Or if you take 7x plus 9 common, then you get x minus 1 is equal to 0. So from there we get x is equal to minus 9 by 7 and x is equal to 1. So we are getting two different values of x. Now if I put x is equal to 1 here, so this will become 2 plus 5, 7 plus 7, 14 minus 10. That is not 0. Means this is not a root. If I put x is equal to minus 9 by 7, we will have to check if this expression is 0 or not. If this expression, any of this expression is 0, then other will also be 0. And in that case, this will be the common root, or it won't be the common root. This is what it says, that not only we need to subtract it, we also need to check that for the value of x that we get from here, for that value of x, is fx is equal to 0 or gx is equal to 0, then it will be a common root, otherwise it will not be a common root. Okay, like by subtracting we are getting x is equal to 1, but by putting x is equal to 1, this is not 0, x is not the common root. अगर ये रखने से -9 by 7 रखने से ये 0 हो जा रहा है, फिर हम बोलेंगे कि ये कॉमन रूट है ना, अदरवाइज कॉमन रूट नहीं है. Okay, then more properties of polynomials, as you can see on the screen. Check out these concepts. I'm sure you must have learned these concepts during your live classes or the practice that you have done before. Okay. So what do we know about this? This is the same polynomial that we discussed about. This is the format of a polynomial, right? And if a polynomial is like this and there are some roots, roots are r1, r2, r3 till rn. If power degree is n, there will be n roots. Degree is 2, there will be 2 roots. If degree is 3, there will be 3 roots, and so on. So in that case, we can say sum of the roots, sum of all the roots will be equal to minus a1 upon a0. a1 is coefficient of x to the power n minus 1. Okay, sum of the products of the roots, taken 2 root at a time. दो रूट को एक साथ लें अगर, उन सब का सम a2 by a0 होगा. If you are taking 3 roots at a time, sum of those will be minus a3 by a0. If you are taking the product of all the roots, it will be minus 1 to the power n into a n to the divided by a to the power a0. Okay, this is how we find the relation between the roots, right? And this is known as properties of roots. What will be the sum when one root is taken? Sum of all the roots has been taken. What will be the sum when sum of product of two roots, all the possible two roots are taken? What will be the sum then? So again, if this is confusing to you guys, let me explain it using example. Like let's say one of the equation is x square plus 7x plus 7x plus 3 is equal to 0, has roots. Roots of this equation, roots are alpha and beta. Then what we can say, sum of the roots alpha plus beta will be equal to minus 7 upon 1, which is this one. Okay, minus a1 upon a0, coefficient of x divided by coefficient of x square. Then what will be the product of roots alpha beta? This will be equal to 3 upon 1. Okay, the constant term divided by 1. We are taking two roots, so minus 1 to square will become 1. Now if you are taking three roots, let's say x square, x cube minus 7x square plus 6x plus 8 is equal to 0, and let's say roots are alpha, beta and gamma. In that case, what we can say, that alpha plus beta plus gamma, taking one root at a time, this will be minus of minus 7 by 1, which is, let's write it as 2x cube. It will be much easier to understand then. Then this will become minus of minus 7 by 2, which is equal to 7 by 2. Sum of roots, we don't know the roots yet, but we can find the sum of the roots of this equation, okay, which will be 7 by 2. All right. Now, if you took two roots at a time, sum of products of two root at a time, alpha, beta, beta, gamma, gamma, alpha, sum of products of two root at a time. So, what do? We take the coefficient of x, which will be 6 divided by 2, that will be equal to 3. Then, if you are taking product like alpha, beta, gamma, in that case, what will be the product? It will be minus of 8. What was this? This was minus 1 to the power n, product of all the roots, minus 1 to the power n. So, this will become minus 1 to the power 3. We are taking 3 roots, minus 1 to the power 3 into 8 upon 2, which will be equal to minus 4. Okay. So, this is how you can find the sum of the roots, taken one root at a time, taken two roots at a time, taken three roots at a time, and so on. Okay. Let me know if you need more examples or examples of higher degree equations here, because see, you won't be asked to solve a cubic equation or equation with degree 4 or equation with degree 5, but you will be asked question like this: what will be the sum of roots taken 3 roots at a time? What will be the sum of product of roots taken 4 roots at a time? You can be asked question like this. Okay. ठीक है, is this clear to everyone? Tell me. Okay then. Now next part, quadratic equation. What is the general form of quadratic equation? The general form of a quadratic equation is ax square plus bx plus c is equal to 0. है ना? One way to find the roots of this quadratic equation is using the formula, right? Minus b plus minus square root of b square minus 4ac upon 2a, which you will find written later. But one way to find the roots is roots are minus b plus minus square root of b square minus 4ac upon 2, right? This is how you find the roots here, the roots of this quadratic equation. And if alpha beta are the roots, if alpha beta are roots, then what is the root form? Then root form of a quadratic equation, then the root form of a quadratic equation will be equal to x square minus alpha plus beta x plus alpha beta, or we can also write it as a into x minus alpha into x minus beta. This is equal to 0 or this is equal to 0, है ना? This will be the root form. If both of the roots are given, you can find the equation like this. Okay, this a we can take right side and still it will make the same sense, right? Now if we talk about more about quadratic, then what can we say? That we already know the roots. This is how you can find using the formula. Now the important part is discriminant, है ना? Discriminant, it's 2a. Where, Shreya? In formula. अच्छा, sorry, हाँ यहाँ पे ना it was 2a. Sorry, I forgot to put a here. It's 2a. Right. Yes, Shreya, thank you. So here where discriminant d is equal to b square minus 4ac. Now this b square minus 4ac is under square root, and because of that we can say that there are nature of roots. Nature of roots means roots will be real, roots will be imaginary, or roots will be equal, rational, irrational. When are those possible? What do we know about discriminants so that those are possible? So here it is. First of all, starting with the fourth point, if discriminant is less than 0, then we say that roots are imaginary, roots are not real. Okay, but if d is greater than equal to 0, roots are real. Now these three are part of this fifth one only. Okay, these three are part of this fifth point only. If d is greater than 0 and a perfect square, b square minus 4ac is a perfect square, that means we get an irrational a rational number outside, right? So in that case, roots are rational and distinct. If d is greater than 0, not a perfect square. If b square minus 4ac is not a perfect square, this square root of this will become irrational, and so both the roots will be irrational and conjugate sorts. Then if d is less than 0, in that case the roots are imaginary. We have already done this. Point 3, when d is 0, when d becomes 0, if this becomes 0, then there will be only one root, which is minus b by 2a, right? Minus b by 2a. In that case, roots are rational and equal. Okay. So this is about the nature of the roots. The nature of the roots if it is given that equation is given, we need to find what will be the nature of the roots. Are they real, are they imaginary, are they rational or equal, so in those kind of situation we can use these concepts. Okay. Now next is change of roots. Now this is very interesting, and these are some really good shortcuts. Okay. See, change of roots. If given that there is an equation and their roots are alpha and beta, then we need to find another equation whose roots are alpha plus 1 and beta plus 1. Then we can say that equation will be this. You replace x by x minus 1. If we need to find that roots are alpha minus 1 and beta minus 1, what will be the equation? You replace by x plus 1 to x. And then if roots are k alpha, k beta, then this will be the equation. Roots are alpha by k, beta by k, you replace x by k into x here, you get the equation. If 1 by alpha, 1 by beta, you replace x by 1 by x. So note it down, I will give you a few examples to understand this properly. So if question is like this, let's say, let's take an example to understand these concepts, that if alpha and beta are the roots of the equation, let's say 3x square minus 4x plus 7 is equal to 0, then find the equation whose roots are alpha minus 1 and beta minus 1. Now can you solve this question? Try this one. This is definitely under your syllabus. Okay, this question is definitely, because this is pretty much quadratic equations only, right? So try this question. Can you answer this? Can you use the concept that we discussed just now and solve using that method? Anyway, if you know it before, then try to solve it, or you can use the concept that we learned here and then you can solve it. Let me know your answer. 3x square plus 2x plus 6 is equal to 0. Okay, let's check it. What do we need to do? Alpha became alpha minus 1, beta became beta minus 1. So find the equation. We need to replace x by x plus 1. So what will be the equation? 3 x plus 1 whole square minus 4x plus 1 plus 7 is equal to 0. Or if we expand this, this will be 3x square plus 2x plus 1 minus 4x minus 4 plus 7 is equal to 0. Or this will be 3x square, 3 into 2, 6x minus 4x is minus 2x, sorry, plus 2x, then plus 3. So 10 minus 4 is 6, plus 6 is equal to 0. 3x square plus 2x plus 6. Yes, Shreya, that is absolutely correct. You know, this will be our equation. So this is how you can find it effortlessly. Otherwise, what you will have to do, you will have to find the sum of the roots from here, the product of the roots from here, both of them are fraction. Then you will have to find the sum of the roots, new sum of the roots, the new product of the roots, and then you need to apply it into the equation, then you will get your answer. So you can skip all those steps and you can simply use this. Okay, 3x square plus 2x plus 6. Now similarly, if it says that another example, that alpha and beta, or see, let me write a different language of the question. Find the equation, find the equation whose roots are half of the roots of the equation 3x square minus x plus 5 is equal to 0. Okay. Find the equation whose roots are half of the roots of the equation 3x square minus x plus 5. So how do we solve this? What will be our answer in this case? So what will be the answer? See, check the concept. If alpha and beta are replaced by alpha by k and beta by k, then x should be replaced by k into x. So what we can say, if the roots are, previous roots are alpha and beta, this became alpha by 2 and beta by 2. This became alpha by 2 and beta by 2. So replace x by 2x. So in this equation, 3 into 2x whole square minus, it will be 2x plus 5 is equal to 0, or this will be 12x square minus 2x plus 5 is equal to 0. This will be our equation, है ना? 12x square minus 2x plus 5 is equal to 0 effortlessly, है ना? शॉर्टेस्ट टाइम पॉसिबल। ठीक है, बताओ। As I said in the previous question as well, that other way to solve this question is you find alpha plus beta from here, you find alpha into beta from here, then you find sum of these two, then taking that previous result in reference you will find it, then you multiply these two, then you will find the result, and then use the roots formula to find the equation, है ना. What is root formula? X square minus sum of roots plus product of roots, x square minus x into sum of roots plus product of roots is equal to 0. Sum of roots plus product of roots is equal to 0. This is what we call a root form as well, है ना. Now if we talk about maximum or minimum value, maximum or minimum value of a quadratic expression, how do we find it? Okay, instead of maximum or minimum you can say maximum and minimum कह लो, है ना. So let fx is equal to ax square plus bx plus c. Okay, so first point, when a is greater than 0, then we can say that maximum value of fx will be equal to c minus b square upon 4a at this will be infinity, maximum value will be infinity plus infinity, the maximum value will be plus infinity, but what will be the minimum value of fx? The minimum value of fx will be c minus b square upon 4a at x is equal to minus b upon 2a. ठीक है, minus b upon 2a, you get the minimum value of this expression. All right. Similarly, if we say when a is less than 0, then we can say that maximum value of this fx, this quadratic expression, will be c minus b square upon 4a, where at x is equal to minus b by 2a. Same expression at the same value of x and the minimum value of fx will be equal to minus infinity. Okay, in case a greater than 0, we will have maximum value plus infinity and minimum value will be c minus b square by 4a. In case of a less than 0, we will have maximum value of fx as c minus b square upon 4a and minimum will be minus infinity. Okay. है ना. So today we were able to cover lots of things about algebra, starting with proper basics, right? Starting with proper basics, which were important algebraic formulae, right? Important algebraic formulae के बाद we learned about rules of indices. Okay, then we learned about concept regarding linear equations. The most important part of linear equations are equations with two variables, which are these, है ना. Said this is applicable for all. Okay, yes, this is enough for JIPMAT. Okay, then general equation. We learned about the general equation of nth degree and polynomial of x and the details about the roots, the properties of roots, okay, which is this. And then comes some examples I gave you, that how do you find the equation if roots are given. Then some more rules about the polynomials and about the roots, the relation between imaginary roots, the relation between irrational roots, है ना. Then we also learned about the common roots between two different polynomials. Then this is again the important part, properties of roots is what we learned about. We saw few examples as well. Then we came to quadratic equation. How do we find the roots of the quadratic equation? Using the formula or using the factorization like this. Then we learned about the nature of the roots. Nature could be real, when it could be imaginary, when it will be rational, when it will be irrational, when those will be equal, right? So nature of the roots we got to learn about. Then what happens if roots are changed, like an equation is given and some in the another equation is asked where roots are somehow related to the roots of previous equation. Then we can use these concepts. Okay, few examples on the basis of that. This is one, this is second. And then we learned how to find maximum or minimum value of any quadratic expression, right? The if we have a greater than 0, then we can find the minimum. Maximum will be infinity always. If we have a less than 0, then we can find maximum. Minimum will always be minus infinity. Okay. So that almost cover everything, right? From equations and indices, right? So tomorrow I'll be back, and tomorrow we are going to discuss concepts from logarithm and modulus and inequalities. All right. So thank you for joining us today. Bye bye. Shade for quadratic equations you can practice from dashboard. Okay, go to iQuanta.in, log in, and you can practice from there. All right.